Okay, we're going to start lecturing here, and like I said, just to hopefully try to get on pace a little bit. So, chapter one, I'll be honest with you, there's not much in there. So, the only thing you need to worry about from chapter one is kind of the scientific method. It's actually on these handouts, the PowerPoints, if you want to look through it. I might post up online just a little short little chapter one part, but really you don't have to worry too much about chapter one. I'm probably not going to ask too many questions on the scientific method, but of anything out of chapter one, that's really what you should kind of look at. You technically be responsible for that part of it. So we're going to get into chapter two, which is really the heart of starting this class, and we're going to talk about measurements. In this chapter, we're going to talk about how to properly take measurements. We will talk about different types of units. We'll talk about conversions. We'll also do dimensional analysis, which is, as we'll talk about when we get there, essentially the way they want you to show your work in chemistry is by you doing dimensional analysis with units, which we'll show some examples of. And I think we'll finish up there with some density at the end of this chapter. So measurements are really important, and it's really important because, for example, if I did 100, really, what does that mean if I just write the number 100? You have really no frame of reference for what that 100 means. It can mean I have $100, which would be really good. It could mean I have 100 pennies, which is really good. It can mean I have 100 hot dogs, probably pretty good if I'm hungry, I suppose, right? All those things. So without a unit, it's really useless, the number, right? Because nobody really knows what we're talking about, right? So, if I put 100 pennies, now I know, okay, that is what I got. That is a certain amount of money. I have a reference for what that 100 means. So whenever you take measurements, it's really important to always have the number, and you should always have the unit. And that is super important here. As you might imagine, they will dock you for sure, probably in lab, if you don't put units on calculations. You don't write units on exams and quizzes, you're going to be in trouble. So whenever you take a measurement, there should always be a number and a unit associated with it. Now, when we talk about units, there's actually different types of units that we have. And the two kind of common types of units are the English units. They're also sometimes called the US units. And then pretty much that's what we use here in America. And everybody else pretty much uses the metric system. So everybody else around the world pretty much uses the metric system. And as you can imagine, as the world got smaller in the sense of people doing business and working together in different countries, that's kind of problematic, as some people here in the US is using US units, and some people maybe in England or other places in Europe, they're using the metric system. There's going to be some problems. So in 1960, they actually got together in a conference of weights and measures. Sounds like fun. And they actually came up with sort of a unified system of units, which is referred to as the International System of Units, or just abbreviated. A lot of times you'll hear the SI units. And the SI units are basically, for chemistry and sciences, sort of a internationally agreed upon set of units, which frankly is like the metric system, pretty much, kind of the metric system one out there. So it's pretty much based off of the metric system. So a lot of times in chemistry, you'll hear the SI unit for this is that, or the SI unit for that is this. And if we look at some of these are some SI units for different types of measurements. So for mass, the SI unit is the kilogram, abbreviated with the kg. For length, it is meters with the M. For time, it is seconds. For temperature is something that you might not be familiar with, but it is actually Kelvin, and that's a capital K. And if you're not familiar with Kelvin, by the time we're done in this class, you'll be very familiar with Kelvin, because I'll be honest, pretty much every single chemistry formula or equation that you need temperature for, it needs to be in Kelvin. So you do a lot in chemistry in terms of temperature values. You do a lot of conversions between Celsius and Kelvin, which we'll talk about later in this chapter, how to do that. But that's a very common one. Off the top of my head, I can only think of almost like one chemistry formula where they use Celsius and not Kelvin, and that's specific heat, which we'll cover. But probably 99.9% of the time, if you have a temperature value in chemistry, Kelvin's going to be your winning unit there. By the way, the other important thing about units is understanding what those units mean. So, for example, understanding that when you talk about kilograms or grams or pounds, even, you're talking about mass, while you're talking about milliliters or liters, you're talking about a volume. I can't tell you how many people have told me over the years, I asked, what was your volume? And they go, well, it was 50 grams, and grams is not a volume, it is a mass, right? Or I've asked, what is your mass on that? It's 23.56 milliliters, right? And that's definitely not a mass either. So it's really important. Sometimes people overlook that little simple thing of what does that unit represent in terms of the type of measurements you're taking. Are you taking a mass measurement? Does this represent a volume or time or a temperature sort of measurement? So when we talk about these different types of measurements, there's some common ones that we come across for length, volume, and mass. So let's talk a little bit about length first. As I mentioned before, the meter there is sort of the SI unit for length. 1 meter is 39.37 inches. I would say in chemistry a lot, the meter, the centimeter, the kilometer, I'll say even the millimeter are very common units of length that we come across. And some conversions are important. So 1 centimeter equals 0.01 meters. By the way, that is the same as saying 100 centimeters to 1 meter. We get that, by the way, by dividing. Becomes 1, and this becomes 100, basically. So you could use that kind of conversion either way. 1 centimeter equals 0.01 meters, or 100 centimeters equals 1 meter. By the way, this is scientific notation. 1 times 10 to the minus 2 meters is the same as putting it into non-scientific notation, 0.01. The minus 2 means we're going to go 1 and 2 places to the left and put some zeros there, basically, and turn it into a decimal in that particular case. So I would say definitely 1 kilometer is 1,000 meters. That is something that you should know. I would also say whichever one of these you want to remember, 100 centimeters is 1 meter. That is also something that you should know. Again, we use it a lot in here. Once again, as we talked about a second ago, will not be provided for you. So again, make sure that you kind of know those as well. Decimeter, I'll be honest with you, you don't really see too much decimeters happening in chemistry, or at least in my experience, doesn't come across a lot, but you should still know deci as well. Speaking of that, in terms of the metric system, we oftentimes will use prefixes to change sort of the meaning of some of these values. And these are the prefixes: mega, kilo, deci, centi, milli, micro, nano. I would say just off the bat, a little star on this table. You probably have it in your book as well. We pretty much use most of these prefixes along the way. I would say maybe the only one you'll use the least would be still the deci one, but you should know that as well. Now, when we look at the meaning of these prefixes, there's sort of a bigger number meaning and a scientific notation sort of meaning. And most of the time, people kind of look at the scientific notation part of it. And when they try to use the scientific notation sort of meaning of it, oftentimes people will do it incorrectly. And just so you know how to properly do this, for example, if we looked at our friend kilo there, kilo basically means 10 to the 3. By the way, that is scientific notation of 1 times 10 to the 3 is basically what that means when it just says 10 to the 3 is basically 1 times 10 to the 3. We will talk about scientific notation a little bit later on in this chapter if you're not familiar with it, but that's basically what that means. So what does that mean? When you look at sort of these two relationships here between these two guys, what you see in terms of 10 to the 3 is that's how much there is in the base unit to one of the prefix units. So what do I mean by that? So if we took grams and kilograms, right? The base unit in each of these, right, is grams, right? They both have grams in it, right? One's grams by itself and one is kilograms, right? This is the prefix unit, right? That is the kilo. So when we go to this table, in one of the prefix units, there would be 10 to the 3 of the base units. That is the proper way to use that. Can't tell you how many people will do it backwards. They'll go like, in 1 gram, there's 10 to the 3 kilograms, and that's incorrect. So that is not the right way to do it. So when you look over here, this is how much there is in the base unit to one prefix unit. Does it matter the actual units? It doesn't, because if I had meters and kilometers, in 1 kilometer, which is the prefix unit, there would be 10 to the 3 meters. If I had liters and kiloliters, in one of the prefix units, there would be 10 to the 3 liters. It doesn't matter the units, it's the prefix that's most important. It's the same conversion regardless of which one that you do. Now, if we took something like centi, which on here is 10 to the minus 2. And if I had grams and centigrams, that would mean in 1 centigram, there is 10 to the minus 2 grams. Just like if I had liters and centiliters, in one of the prefix, there is 10 to the minus 2 liters. So that is, again, the proper way to use those prefixes. And I can't tell you, again, how many times people will kind of do it backwards and stuff like that. I would also recommend, for example, and we'll talk a little bit more about this later on, but if you're going from, say, prefix to prefix, say you're going from kilograms to, I don't care, centigrams, for example. Sometimes people try to figure out how to go directly from one to the other. And usually they screw up because they're moving the decimal point the wrong way or the wrong way and stuff like that. So what ties both of these together is grams, right? And you can very easily figure out how to go from kilograms to grams using the kilo conversion. And then you could go from grams to centigrams using the centi conversion. So my recommendation is, if you're kind of going from prefix to prefix, just go back to the base unit, because you could very much easily find that conversion and go from the base unit to the next prefix unit, rather than trying to figure out how to go directly one move from one prefix to the next. Again, it usually doesn't turn out so well if you try to do that. Any questions on that there? Again, as I mentioned, probably you should know this table and these prefixes. Yeah. I would say for our class, a lot of times kilo, centi, milli, occasionally a nano, I would think, but definitely 1A as well. You'll pretty much hit all of them. I think you'll use them all. So you do need to know all of them. This is a ruler, and this is the difference between the English, which is 1 inch, and the metric, which is 2.54 centimeters. And that definitely is a conversion you need to know. 1 inch is exactly 2.54 centimeters. That's an exact conversion and definitely something you need to know. That is inches right here. These guys on the bottom are centimeters. By the way, ruler 101, the little guys are what? Little guys are millimeters. Yeah, so little guys are millimeters, 10 millimeters in a centimeter. And then the top guy there are inches as you go across there. Now, volume is the amount of three-dimensional space that is occupied by a substance. The SI unit for volume is meters cubed. And I would say that we get a cubic volume by, if we had something like a cube, we can measure the length times the width times the height. And if we measure each of these measurements in centimeters, each of these individual measurements, they would all be length measurements. But when we multiply them together, we will end up with cubic centimeters, which is a volume. So that's one way you could find the volume of like a cube is take 3 length measurements. And whenever you take 3 length measurements and you multiply them together, you will get like cubic centimeters, you'll get a cubic meter, cubic decimeter. Those are volume readings, not length readings. Each of the individual ones are length. This relationship's important. 1 cubic centimeter is equal to a milliliter. That is definitely something that you should know. By the way, also a cubic centimeter is sometimes referred to as a cc. Like if you watch any medical type shows, give that person 10 cc's of this before they die. Yeah, it says 10 milliliters basically. Yeah. So in the medical field, they give you cc's, which is a cubic centimeter. 1 liter is 1,000 milliliters. That is definitely a conversion that we use a lot in chemistry. So one way that we could get the volume of an object is basically to do some length measurements, multiply them together, gives us a volume. So again, important, each of these individual ones, lengths combined together makes a volume. Any questions on that there? All right, we'll lay it up there.